everyone, to the Digital Engineering 24/7 podcast. I'm here today with Ravi Shankar, Director of Simulation Product Marketing at Siemens Digital Industries Software, and we're going to be talking about the role of simulation and test in a digital twin strategy. Welcome to the show, Ravi.
Thank you, Brian. Good to be here.
Well, to start off, a lot of people talk about digital twins, and we cover digital twins quite a bit, but I don't think a lot of people really understand what they are. So could you talk a little bit from Siemens' perspective what a digital twin is, or what does that term mean?
Yeah, sure thing. And I do agree, digital twin definitions vary quite a bit. So it is useful to understand first what is driving the need for digital twins. And this has to do with increasing complexity that we see across all industries and the opportunities that are afforded by digital transformation. At Siemens, we believe that a comprehensive digital twin is essential to converting this complexity into a competitive advantage. So let me talk to you about what exactly a comprehensive digital twin is. We see it as a precise virtual representation of a physical product or process. It's used across its life cycle to simulate, predict, and optimize the product and the equivalent production system. There is one comprehensive digital twin, and there can be multiple representations as models that can answer different questions about the twin. These models evolve over the life cycle of the product, and they make use of data streams that connect the virtual representation to the physical equivalent.
In that context, then, which areas should companies be focusing on to maximize performance engineering?
Yeah, within this broad context for the digital twin, let us focus on the area of performance engineering, that is ensuring the product or process performs as intended. This is the domain where engineering simulation and testing play a critical role. In fact, this is the beating heart of the digital twin. We see four key areas of focus for companies to invest in that can mature their capabilities in order to take advantage of digital twins. First is to model the complexity that they see for their product or process. This requires the appropriate models with varying fidelity and applicability across different stages of the development process. And it can span methods that include material models, component models, system models, etc. Even models that combine physical systems with relevant software and controls, and even people in the loop. This also means that building the models for all these relevant physics, such as structural, thermal, flow, electromagnetics, and others, is equally important. Once you've built the model, you need to then use the model to explore all the possibilities, meaning exploring the design space, innovating on new concepts, narrowing the selection down to the most promising ones, and then continuing to refine the designs. Emerging areas such as generative engineering play an important role here. Exploration also helps to understand the trade-offs between competing objectives. The third priority is to stay integrated across all functions and organizations. This is important to avoid advancing one aspect of the design only to realize later that it is in conflict with other areas and that decisions need to be reversed. As complexity increases, it becomes critical to connect tools, processes, and people and maintain the traceability across all this data flow so that people can make decisions with confidence, but can also go back and make sure if there is a change that needs to be distributed through the organization, they know exactly what led to that change and who all need to be identified in order to propagate the change. Finally, once you've put all these pieces together, you need to go faster. Competition continues to require speed, even as complexity increases. This means leveraging streamlined workflows, eliminating manual data transfers, using templates and standardized processes. Going faster can be applied at the individual level, at the team level, and at the organization level. The applications that are consumed need to be personalized, modern, and support an open ecosystem that enables speed and flexibility. So all these four areas that I just mentioned are also the key tenets for Accelerator, and specifically the SimCenter portfolio, which is part of Accelerator and represents the simulation test domains for Siemens.
Well, could you tell us a little bit more then about SimCenter and how it really helps companies achieve this type of performance engineering?
So SimCenter, as I mentioned, is our brand for simulation and test solutions within the Accelerator portfolio. And it encompasses methods for 1D simulation, 3D simulation, physical testing, data and design exploration, and data management as well. SimCenter helps companies perform and improve performance engineering in a number of different ways. Our customers are able to design products better using SimCenter and the best predictive tools available. They gain earlier insights through the use of CAD integrated simulation, through system simulation, for instance. They innovate faster with integrated design exploration, access to generative engineering techniques, and the use of techniques such as reduced order methods. They achieve greater productivity by streamlining processes and tying simulation and test to the digital thread. And they see a higher ROI from their investments with Siemens and through the extended applications that they use as a result of our open philosophy that allows our applications to work with their existing ecosystem of in-house and commercial tools.
So I guess to kind of sum things up then, why would companies want to consider Siemens and SimCenter specifically in this type of context?
In our view, no other company offers the breadth of simulation and test solutions that span the full scope of activities, from early simulation architectures to detailed simulation and systems evaluation, all delivered as part of our Accelerator portfolio to ensure fast processes, complete alignment, and full traceability. As an example, let me give you a quote from Clean Motion, a innovative company that's building electric vehicles. And they say, there is a seamless connection from your first design in NX to storing your data in Teamcenter to doing your analysis in SimCenter. It looks like one software. So we invest significantly in enabling this type of behavior that enables companies to achieve a much more productive product development workflow. In addition, we offer an unrivaled wealth of expertise in engineering and a dedicated support model. For example, we have a quote from Karma Automotive, who say that by using Siemens consulting services and software tools, they were able to get it right with a minimum amount of iterations. Our customers know that with Siemens, they have a partner with the resources and dedication to help them in every step of the digital journey.
Thank you very much, Ravi. Thank you again for your time, and we hope to talk to you later.
Thank you.